Hello, young ladies and young gentlemen. As part of the Memory Chip, Understanding the Memory Chip series of YouTube lectures, I have a lecture on mutable values and immutable values that I've split up into two videos. This is the second of two videos about mutable values and immutable values. And both of these videos are part of the series on understanding the memory chip when a computer program runs. So, this is the second of two about mutable values and immutable values. You just, I assume, watched the first, and this is the second of the two. So, X is an array. X points to a location on the memory chip where you have an array value. And then, by doing this, I made a modification to the array. And then after I do this, the array is now this. One part of the array, one value inside the array has been changed, 0.7 to 123. Everything else is the same. And of course, the location on the memory chip where the array is, of course, does not change. So see what I've done here. The array was this, and now the array is this. And see how this happened. I made a modification to the array. The location on the memory chip where the array is stored does not change. I did not completely destroy the array and replace it with a brand new array. I only made an alteration to the existing array. So what I did not do is destroy the array, destroy that value. Now there's no value there at all, and then put a brand new value there. That is not what I did. I made an alteration, an internal alteration to the existing array. This array is the same as this array, same location on the memory chip. I just changed one piece inside. That is a situation where I have, therefore, shown that an array is a mutable value. An array is not an immutable value like a number. An array is a mutable value because I can change something inside the array while the array's location does not change. I modify the array in place and I take a piece inside the array and I change it. Therefore, an array is a mutable value. Now, remember in the earlier lecture I did x equals 6 and then x equals 5. I did two assignment statements in sequence, x equals 6 and x equals 5. This is the same thing, the same logic. Okay, so I'm assuming that strings are immutable values, unless I say otherwise, which means they're like numbers. Okay? So here I assign x to be cat, then I assign x to be hat after that. Okay, what happens is that the variable name x is reset to point to a new location on the memory chip where the value hat is. So x was pointing to an older location on the memory chip. X is reset to point to a completely different location on the memory chip. And so the value cat and the value hat are at completely different locations in the memory chip. Again, as with the x equals 6, x equals 5 example, this example here is not what I mean. This example here is not what I mean when I talk about mutable values. Okay? It's the same logic, the same explanation. Cat is at one place in the memory chip, hat is completely different, and I'm not changing a value in place. I just change where x points to on the memory chip. Now, I'm going to show you an example that's a little bit less common, at least today, and a little bit more subtle. But let us now assume that we are using a programming language where the designer of the programming language decided strings are mutable values. Ruby is one such example. Meaning, the designer of the programming language decided, I will make strings such that you're allowed to keep the string, but you change one letter. So cat, C-A-T, can be changed to C-U-T by modifying one letter in place, not by completely rewriting the string at a different location. Okay? There are still programming languages in use today where strings are mutable. The string's location on the memory chip does not change, but you take one letter inside the string and you modify it. Ruby is such an example, and older computer programming languages are also examples. So what happens there is I do this. When the programming language designer made that decision, what that means is that a string of text is basically an array where each element in the array is a single letter, or what they say is a single character. Sometimes it could be white space or punctuation characters. So I do x equal cat, and then I do x0 equal h. C is replaced by h. I can only do that because I'm using a programming language where strings are mutable values. If that were not the case, I would not be allowed to do that. If I tried to do that with other languages, I would get an error. See, unlike a number, a string has a string internally has multiple pieces inside. So the string cat has 3 letters inside. The string road has 4 pieces inside, 4 letters. The string Panama has 6 pieces inside, 6 letters or characters. You see? So a string does have multiple pieces inside, meaning the language designer can choose to make strings mutable values if he so chooses. And the designer of Ruby made that choice. The designer of Python made the opposite choice. So take a look at what I did here. I did not destroy the string cat. This string is still there, but it changes to this, but it's the same string. I did not destroy the string cat. I did not change the location on the memory chip of the string cat. The only thing I did was I changed one little piece inside. So I only changed one letter. So where on the memory chip the letter C was, that's the only change I made from letter C to letter H. So this example here, this is an example that demonstrates a mutable value. So what I was explaining earlier is that some examples, if you're confused, you might think that's an example of a mutable value, and I had to carefully explain that it was not. But in this case, this is an example that demonstrates, in fact, a mutable value. And remember, this is only possible where the designer of the programming language decided that strings would be mutable. And that does it. This is the second of 2 YouTube lectures that deal with mutable and immutable values as part of a series of lectures that explain what you need to know about what's happening on the memory chip when a computer program runs. And so when explaining what is happening on the memory chip and why that sometimes matters when writing computer programs, one of the things you need to understand before you practice with the memory chip and understanding the memory chip, one of the prerequisites to understand that is understanding the difference between mutable values and immutable values. And this ends my lecture on mutable values and immutable values, which I have split up into 2 YouTube lectures because of time. Thank you.